our show. Since the turn of the 21st century, energy costs have risen steadily. Energy forms a sizable share of operating cost. Around the world and across sectors, getting smart about energy has been seen as a strategic imperative. It is in this scenario that the efficient use of energy becomes important.
The main purpose of accumulator control was to enable the steam supply plant to reach an otherwise unreachable peak, but did not reflect the need to maximize boiler efficiency. Currently, the picture in the modern boiler house is different, and the need for industry to continuously reduce its energy bill through improved operating efficiency is a priority. The latest accumulator control methods are a far cry from those of the old days and are now designed to optimize boiler efficiency in conjunction with today's modern burners. In textile industry, many of the dyeing and bleaching operations are carried out in batch process. There was a steam load difference throughout the day, resulting in losses as boiler had to be maintained running at higher pressure. This led to an increased steam requirement from current boilers during peak load hours. This increase in load jerk was resulting in the boiler pressure dropping down and sometimes dropping below the recommended operating pressure range of the boiler, which leads to problems like water carryover resulting in poor quality steam supply, increased maintenance or operating costs, reduced boiler life and efficiency, increased process time, and reduced product quality. To optimize the boiler efficiency based on findings in the audit, the energy management team of a designated consumer decided to install a steam accumulator to cater the requirement at peak loads instead of increasing the capacity of boiler.
We were always in the shortage of steam. We were operating 3 boilers at a time, 1 boiler always in operation and 1 oil-fired boiler in standby mode to meet the intermittent requirement of the steam, and the 3rd boiler was kept as a standby mode for the coal-fired boiler. We added 1 steam accumulator in our new brownfield project, and we really achieved a good saving from that steam accumulator system, and that gave us another instinct to go for the horizontal replication of this, and we added another steam accumulator for our old linen spinning plant. There we also got benefited. Earlier we were operating 3 boilers, 1 boiler continuously in the operation, 1 oil-fired boiler to meet the intermittent requirement of steam, and 1 as a standby. And touch wood, from last 1.5 years we have not operated any other boiler. We are working with 1 single boiler at a time, and that is quite enough to meet our steam requirement. So that has saved a lot in the form of carbon emission and the GHG emission, and we have met our steam requirement at a reduced price. All process departments are very happy with us.
The working principle of steam accumulator is interesting to note. When high pressure saturated water is exposed to low pressure, a percentage of this water will flash off into steam through using the remainder sensible heat in the water. The proportion of flash steam depends on the difference in pressure at which the hot water is exposed. When plant experiences low steam demand and the boiler can generate more steam than it needs, the unused excess steam is injected into water that is stored under pressure inside the accumulator. The most important energy cost savings to be gained from steam accumulation derive from a reduction in the boiler output in combination with load stabilization.
With the conversion of waste to wealth, now we can say that installing a steam accumulator would bring about a huge reduction in boiler, thereby reducing the cost of a boiler, installation cost, operating cost, and increased boiler efficiencies. That's all for today. We'll be back with more energy conservation technology in future. Till then, goodbye.